Alright, this is page 2 of review worksheet for chapter 11, and number 10 at the top, I've got a geometric sequence with two of the terms given, and I'm supposed to find the common ratio. So I've got the 11th term and the 4th term. So first I'm just going to frame this. I know to get to the 11th term, if I want to start with the 4th term, then it has to be multiplied by the common ratio, 11 minus 4, or 7 times. So since I know the 11th and the 4th term, I can plug those in to say that 6,588,344 is equal to 8 times the common ratio to the 7th power. Then I divide both sides of that by 8, and I'll get r to the 7th on one side is equal to 823,543. So then I want to raise both sides to the 1/7 power. And when I do that, I get the 7th root of this 823,543. So the common ratio is equal to 7. Okay, number 11. I have the sum of an infinite geometric series is 9, and the first term is 6. So I know that the sum of an infinite geometric series is just going to be the first term over 1 minus the common ratio. So in this case, I know the sum is 9, and I know the first term is 6, and I have to find the common ratio. So multiplying both sides by 1 minus r, I get 9 minus 9r is 6. So negative 9r is negative 3. So dividing both sides by negative 9, r is equal to 1/3, and that is choice B. Okay, number 12, I have to find the sum of this arithmetic series. I know the first term. I don't know this term number, and I don't know the number of terms as a result of that last term. So I remember that the sum of an arithmetic series with n terms is n times the first term plus the last term divided by 2. That's Gauss's formula. So in this case, I first have to find this last term. So if I look at what's happening from 3 to 19 and 19 to 35, I'll see that the common difference is 16. I'm adding 16 to each term. So first let's find what that term value is. So the nth term in this sequence is going to be equal to the first term plus n minus 1 common differences. So 307 is going to be equal to 3 plus n minus 1 times 16. So I'm going to solve this for n. So 320 is 16n, so dividing through I get n is 20. So that must be the 20th term. So then I can put that into the nth term formula, and I'm kind of running out of room here. So I'm going to flip onto this other sheet. So the sum of the 20 terms of that sequence is going to be 20 times the first term of 3 plus the last term of 307 divided by 2. And when I do this, I get 3,100. So this is choice D, 3,100. Okay, and number 13, this looks to be a series that's going infinitely, and it's a geometric series, it looks like, and its common ratio is, what do I multiply 3 by to get 3/7, and then 3/7 to get 3/49. When you figure that out, that's a common ratio of 1/7. So this should be equal to the first term over 1 minus the common ratio. So the first term is 3 right here. So 3 divided by 1 minus 1/7 which is 3 divided by 6/7, which is 3 times 7/6. So this is a 1 and a 2, so I get simplified 7/2, which is choice D. Okay, number 14, we have the sum of an arithmetic sequence is 126, first term 4, last term 24, find the number of terms. So this is the same formula that I used right up here in number 12. So I'm going to plug in the sum, 126, that I know is equal to the number of terms that I don't know, times first term of 4 plus last term of 24 over 2. So multiplying both sides by 2, I get that 252 is equal to, this would be 28n. So when I solve that, I should get n is equal to 9, which is choice A. Okay, in number 15, I've got boxes stacked in a warehouse, 37 in the bottom row, and then 35 in the next row, all the way up, and in the top row, I just have 2 boxes. So they want to know how many total boxes are in this stack. So it doesn't matter, I can look at this, 37 is the first term, and, oh, I'm sorry, this is 32. It's going down by 5. And 2 is the last term, or 2 is the first term, and 37 is as the last term. It doesn't matter. So I'll look at 37 as the first term in this sequence, and then it goes to 35, and then all the way down to 2. And I can see that my, oh, I'm sorry, it goes to 32. My common difference is -5. So I need to find out how many terms are in this sequence from 37 down to 2. So I know that I can use this formula. So I can say that 2, being the nth term, is equal to the first term of 37 plus n minus 1 times -5. So I'm going to solve and find out how many terms, in other words, how many rows of boxes there are. Oops, this would be -5n plus 5. So 2 is equal to 42 minus 5n. So -40 is -5n, so n is 8. So there are 8 rows of boxes. So now I'm going to, again, I've run out of room, so I'm going to get another piece of paper here and continue. So I've got, now I know the first term in this sequence of boxes, I looked at it as 37. The last term, the nth term, which happens to be the 8th term, is 2, and n is 8. So plugging that into the formula, the sum of those 8 terms should be 8 divided by 2, this is Gauss's formula, times 37 plus 2. So when I do this, I get 156, which is choice B. Okay, continuing, number 16. How many terms are there in the geometric series? First term is 3, common ratio is 2, and sum of the series is 93. So this is going to use the formula for a finite geometric series of n terms is equal to the first term times 1 minus the common ratio to the nth power over 1 minus the common ratio. So in this case, I know the sum is 93. So 93 is equal to the first term of 3 times 1 minus 2 to the nth power, which I've got to solve for, over 1 minus 2. So 1 minus 2 is -1, and if I multiply both sides by -1, then I get -93 is equal to 3 times 1 minus 2 to the nth power. Dividing both sides by 3, I get -31 is equal to 1 minus 2 to the nth power. Subtracting 1 from both sides, -32 is equal to -2 to the nth power. Dividing both sides by negative 2, I get, just by negative 1. Let's divide both sides by negative 1. 32 is 2 to the n. So I know that 32 is 2 to the 5th. So n must equal 5. So that's choice C. Okay, for number 17, I have sigma notation saying take the sum of 20 terms from 1 to 20 of 3/2 j. So first of all, I'm going to figure the first term is going to be 3/2 times 1, which is 3/2. And I know I need the last term, or the 20th term. So that's going to be 3/2 times 20. So that's 30. And then I can go back into this formula that I used in number 12 and say, fill in what I know. So the sum of, this is 20 terms from right here, of these 20 terms is going to be 20 divided by 2 of the first term, which is 1 1/2 or 3/2, plus the last term, which is 30. And when I simplify that whole thing, I get 315, which is choice C. Okay, number 18, we have a worker, and he's being paid 3 cents on the first day, then 6 cents, then 12 cents, and so on. So it appears that this is a geometric series where the amount of money he's making is doubling, and they want to know how much in total at the end of 24 days. So they're looking for the sum. So the sum of those 24 terms is going to be equal to the first term, which is 3 cents, times 1 minus the common ratio, which is doubling, so that's 2, to the 24th power, all over 1 minus 2. And I'll let you simplify that in your calculator, but I get $503,316.45. Okay, number 19, we have a plant that grows each year only 5/8 as much as it did the year before, and it grows 15 centimeters during the first year. So it's growing less and less and less each year to, how tall will it ultimately grow. So this is an infinite geometric series, so we're going to be using this formula that we used right over here in number 13. So I know that the first term is 15 for 15 centimeters, and the common ratio is 5/8. So what this is saying is that the first year it grows 15 centimeters, and the next year it grows 5/8 of that, or 15 times 5/8. And the next year it grows 5/8 of this amount, so 15 times 5/8 times 5/8, or 5/8 squared, and so on. So the sum of this infinite geometric series will be the first term of 15 divided by 1 minus 5/8, the common ratio. So this is 15 divided by 3/8, which is 15 times 8/3. So I have a 5 and a 1, so this is 40 centimeters, which is choice C. And then the last one, number 20, is 8 terms in a series, and we don't know what kind of series that is, but if I divide negative 12 by 3, I get a common ratio possibly of negative 4. So then if you check this out, if you keep multiplying by negative 4, you will see this sequence, or this series, generated, and has alternating signs, which is what happens when the common ratio is negative. So they're looking for 8 terms. So this is going to be the first term, which is 3 times 1 minus the common ratio of negative 4 to the 8th power, over 1 minus negative 4, which is 5 in the denominator. So when you simplify this whole thing out, you should get negative 39,321, which is choice C. So that's it for page 2 of this review worksheet.